We are now gonna start our next theme that's called circular motion. Okay, it's once again movement in 2 dimensions, and we should keep on going. Okay, well, circular motion is motion along a single path or a path or a segment of a circular path. So let's say if you were like going this way and you suddenly start like going and doing this, such that the end of your movement you end up like going that way, you can say you are in circular motion. Okay, those things actually make us like have like lots of things and lots of things to analyze. Okay, well, how to do this stuff? Well, we're gonna work with angles mostly. We're gonna work with angular velocities and angular accelerations. But before that, we should like start checking on some other concepts. Okay, well, first of all, if we're moving in a circular arc, uh, the direction toward the center is gonna call be like centripetal direction. That is, let me change colors from anywhere where the velocity is toward the center. Okay, we're gonna say that that's the center, and that is it. Okay, so that is centripetal direction. This thing over here, centripetal. Now, whenever you move, let's say this is a whale, uh, and you move in a circle at a constant speed, you're gonna have a velocity, the normal one that we have checked like previously, and that velocity is going to change through time. That is like this one. Okay, but when you actually move, you're going to start like generating little angles. Okay, so this angle over here is exactly this very same angle that you're having over here. Okay, so the changes of the angle of our velocity is going to generate changes in the angle that is like on the velocity once again, and the changes in velocity once again are going to be acceleration. Now, the radius should be the same at all times. Okay, if the radius is not the same at all times, there's like a different type of analysis. But for now, we're going to assume they're the same. Okay, so once again, this angle is going to be exactly this one. Okay, and you need to make sure that this velocity vectors, the ones I'm just putting in red, should be perpendicular to the radius. Okay, you know they're perpendicular whenever they form 90 degrees respect to the radius. Okay, so things to remember. There are some concepts we need to know. Centripetal acceleration can be computed whenever we have this. V is just like linear acceleration. Linear acceleration. And R is just the radius, okay? Remember, for this to work, the radius should be constant, and the velocity, we're going to analyze it just at any point, okay? Well, if we have like the motion of a particle moving in a constant circle, we're going to have something funny called period. You should have checked that in middle school. The period in this time is the time it takes something to just go around something in a motion of a circle, okay? So that duration is going to be t, and that thing is called as a period. This thing over here, okay? During that period, the particle is going to travel 2 pi r distance, okay? Now, this is exactly the same as writing, once again, middle school, as writing 2 pi r and f. F is going to be the frequency. You need to remember some basic concepts of middle school in which you check like the relationship between frequency and period. So you know that the period is the inverse of the frequency. Okay, therefore these two formulas are going to give you the exact same value.